Well, welcome to Cooper Hewitt Smithsonian Design Museum. My name is Kim Robledo-Diga. I'm the Deputy Director of Education here at Cooper Hewitt. As the nation's design museum, we have a fantastic commitment to fostering and celebrating young designers like yourself. As part of our commitment, Cooper Hewitt is holding its second annual call for student entries in conjunction with our current exhibition, The Road Ahead, Reimagining Mobility. We challenge the students to answer the question, how might automation change the mobility of people, goods, and services? Submissions came from universities across the country, and 5 projects were selected to be exhibited in our Road Ahead Reimagining Mobility exhibition. Today we have with us those young designers representing those 5 projects from the University of Michigan, Harvard University, University of Washington, Kane University in New Jersey, and Arizona State University. So today they'll each present their projects to a group of designers and experts, not just their design project, but their process, and hear feedback from them and their peers in the room. Which leads me to welcoming our guest panelists. We have Ryan Powell, who leads the UX research and design team at Waymo, a talented group of researchers and designers taking a human-centered approach to design of the world's first driverless ride-hailing service. He is an accomplished design leader with deep experience in consumer products. So let's say hello to Ryan, who's right here. And to his left, we have Jack Robbins, who's Principal Director of Urban Design, FX Collaborative here in New York, who works with the public and private clients to create vibrant, sustainable cities. He brings a design-oriented approach, an international experience to creatively solving complex challenges with a keen understanding of the designer's responsibility to the public. So let's welcome Jack. And we're missing one expert panelist who's meant to join us today, Sarah Williams, who got caught up in the grounding of flights today with the wind, for all you experience wind today. I'll give her a bio now, but I'll actually introduce first Ruki Ravi Kumar, who's to the left of Jack. She is the Director of Education here at Cooper Hewitt and also a designer herself. So she'll be participating and giving feedback, and then when Sarah comes in, she'll join the team. So Sarah Williams, who should be joining us a little bit shortly, is Associate Professor of Technology and Urban Planning. She's also Director of Civic Data Design Lab at MIT's School of Architecture and Planning. The Civic Data Design Lab works with data, maps, and mobile technologies to develop interactive designs and communication strategies that expose urban policy issues to broader audiences. So I'm going to welcome actually the first presenter, and I figure that's when we present, each of you can introduce yourself and your teammates. Does that sound fair? And so our first presenter here today is going to be Emmanuel from the University of Michigan, who's going to present about his design future bus. And as a reminder, we'll have about 10 minutes to give for Emmanuel to present, and then get feedback from everyone in the room. Excellent. Well, welcome, invite Emmanuel up, and we'll just do a little dance here with laptops.
Hello everyone, my name is Emmanuel Papageorgiou and I'm a senior at the University of Michigan Penny W. Stamp School of Art and Design. I'll be graduating with my BFA this April. I began conceptualizing campus transportation last summer, where I was compiling my graduate school portfolio for architecture, and I wanted a project that spoke to architecture, transportation design, and my love for graphics and product design. Today we're going to be looking at specifically the Ann Arbor campus of the University of Michigan, and for those of you who are not familiar with the city of Ann Arbor, it is due east of Detroit about 45 minutes, due west, for about 45 minutes, and could be considered a secondary city to Detroit's primary city. It has a population of 112,000, and of those 112, 70,000 are university students or faculty. So the existing system has to tailor to that large density every single day at various times of the day. Looking specifically at the university campus, it's separated into 5 different campuses. However, 2 are mainly used by students. On Central and North Campus, there's a mix of academic buildings and student dorms, which is where most classes are held, while South Campus holds all the infrastructure for the for the athletic stadiums and buildings, while the East Medical and Medical campuses house all the hospitals. The current system has many problems, as I've lived through for the last 3.5 years and have discussed with my friends on campus, some of which can begin to be that they are all on the street and are exposed to the cold Michigan winter. We just experienced a polar vortex, so I'm sure you can imagine how it feels to be standing outside in negative 15 degrees weather, as the picture on the left illustrates. Furthermore, the Central Campus Transit Center has a meridian dividing both loading structures, and that makes crossing between really unsafe. Looking specifically at those 4 campuses, what appears now in purple are the university buildings. Now these are the dorms on both campuses, and that is all with the inclusion of the athletic buildings. And so you can see that there's a need to connect these 3 campuses. That is a fundamental need. When we look at the current system, we can begin to discern that there is a large overuse of the same roads. And as I click and begin to show all these routes that the current system uses, you can see that that central road is being used by over 9 routes. And what is going to appear now in red is actually serviced by 9 routes. So over 9 different bus routes are going on that street. And what appears in light blue is serviced by 3 routes. So there's an overusage of routes, of streets, and it is an inefficient way to solve how people can travel around these 3 main campuses. Again, looking at that from above, you can see the street in the center becomes to be very dark as all those colors are overlaid one on top of the other. Traffic during the peak transit hours begin to illustrate how those 3 campuses need to be connected. As you can see, the hotspots do represent the central areas of each campus. The proposed system that I'll be presenting today takes the campus and separates it into primary routes and secondary routes. The primary routes are served by campus connectors by 2 different buses, one that will be running 24 hours and another that will run during the peak transit hours. The high density route connects hotspots on all 3 campuses and is a loop, so we'll be continuing with unrestricted and unstopped flow 24 hours a day with the bus that appears on the bottom. From there, the campus commuters would take students from stops on the primary route to campus outskirts, which could be dorms or other locations on either of those 3 campuses. That route is served by a smaller bus all times of the day, while during peak transit hours, a larger bus would come out to serve that added density need. Students can transfer between primary routes and secondary routes 14 places throughout those 3 campuses, and that would happen at the transit hubs, while the campus transit center serves as a central nucleus for this entire system. When you compare the system that I'm presenting today with that existing, there is not only a reduction in the bus stops and the primary routes, but the new system is more efficient with less overuse and less pollution, as the mobility solutions are both autonomous and electric. I would like to say that as a disclaimer, this was a top-down conceptual design, so these autonomous buses do not feature any LiDAR sensors or any other sensors that we actually just took a look at upstairs. The low-density commuter routes would be served by a small, low-density design bus that would fit 20 people, and this bus would run 24 hours a day, 16 feet by 8.5 feet tall, and features a exterior structure that is in blue to color coordinate with the route, but the glass can connect the interior with the exterior landscape. A look at the interior. The high-density routes would be served 24 hours a day by this design, and it is a similar concept to what we just looked at, and I'm trying to maximize the use of glass within the design. You can see on the top I've also included a bay for the bus to be able to drive in and recharge electrically. And during peak transit hours on the primary route, a articulated accordion bus would come out onto the system and be able to move over 130 people at any given time throughout the 3 campuses. This would help significantly as students have to come between those 3 campuses. A lot of students live on Central Campus but need to commute to another campus for school, and so between 8 and 12, a lot of students will be needing to take the bus and to commute to another campus. The interior of the buses was inspired by seating that can be found in many metro systems. Particularly, I was looking at the ones of the London Tube and the Paris Underground, where you have the ability, whether you'd like to sit on the inside or stand, the chair can fold out and will provide comfort in either of those seating or standing positions. This illustrates how you can decide whether to sit or stand with the chairs folding out at different opacities. When applied to the interior, the low-density design just features one row of these chairs, while the high-density design features a row of these chairs with couches around, and the maximum density features more of that. As you can see here, the high-density routes interacting with the low-density routes, and then each of these low-density routes would serve to access a neighborhood on campus where students live at, and so then they'd be able to come back into that central route and go up to the 3 different campuses. Those transit hubs, as I mentioned earlier, are the place where we can make that transition, and finally the Central Transit Center would be the nucleus of that system. Looking specifically at the Central Transit Center, I expanded the streets to allow for an improved traffic flow throughout the area, and also shifted the structure into the center to allow for more efficient loading and transfer of routes, and my sketches and process could be shown at the bottom of the page. In addition to that, I also added urban renewal area where students can lounge and enjoy the sun during the summer and study and read. The interior design features color-coordinated bays that would tell the buses where to come in and stop, as well as the users where they can load their buses. Screens would display times of arrivals and departures, and degrooved interior benches allow for unrestricted navigation within the interior program. The Central Campus Transit Terminal also has spaces for those buses to charge. As you can see, both buses can just drive into a charging bay and refill their energy there. 2 buses of each density can fit within those charging bays. The urban renewal can be seen here, and there's an inclusion of buses for that last mile ridden. And finally, I'd like to end with the climate-controlled interior campus transit hubs, which feature a variety of solar panels and bikes for that last mile ride. As you can see, they share the same grooved interior seating and paneled wooden texture. And these are renderings of the system in the current Arbor Campus. At night, students will be protected from the snow, and because it's a 24-hour service, 24 hours system, it allows for the much safer navigation between the 3 campuses. As well as during the summer, you can escape from that humidity. Thank you for your time, and thank you for your selection. It was an honor to have my work in the Smithsonian.
It's very, very nice project, and a lot of elegance to the graphics and the presentation. I wonder if you could talk a little bit about. It seems like the system that you've set up is really dependent on the transfer between the kind of longer routes and the sort of shorter loops, and in all kind of transportation planning, anytime you have to transfer someone, you lose riders.
Mm-hmm.
It's one of the problems we have in New York, and we've been trying for decades to get a one-seat ride to the airport, and it hasn't happened and probably won't happen. But I wonder if you could talk a little bit about how you see that transfer happening.
Yeah, totally. Well, there's different areas of campus, like South Campus, Central Campus, and North Campus, and a lot of times you don't necessarily, when you're on one campus, you don't have to go to another one, you could stay within. So the idea behind the commuters was not only going from one campus, but intra and extra, or within
Right.
and across. As for losing riders, because it's a university system, they're going to be required to go to class. So I'd say that I aimed more to make the climate-controlled interior and a nice space for them to be in and improve what's currently there.
What are some of the things that, when you were thinking about the writers, what types of activities or things do they do during their commute? I would imagine they're probably on the shorter side, the overall commute, maybe like within 10 or 12 minutes or so.
Yeah. So the commute between North to South Campus, which are the ones that are furthest apart, is about 25 minutes. But on that commute, most students are on their phones. Some read, there's some talking. But with the redesign, what I did is I placed chairs throughout the center and then couches throughout. So when you're inside the bus, it's more conducive to social interaction because you're actually facing someone. And then you have the option, if you don't want to face someone, you can just stand or sit at the end of those benches.
One of the other things, I don't know if did you think at all about the sort of maintenance of the buses? I mean, one of the things that's really beautiful about both the buses and the stops is how much glass you have in there, and this wonderful curved glass. But someone's got to clean that glass, and it's got and you talk about climate controlled, but I didn't see any air conditioning units or anything like that.
Yeah,
So
HVAC.
I mean, I wonder, have you thought at all about the sort of maintenance issues? Because again, for transportation systems, a lot of the money is not just the kind of first investment in the equipment and the structures, but in the ongoing maintenance.
Thought a little, not a lot, to be honest. But the current system is serviced by maintenance bay on South Campus, and that was one of my personal, not only desires, but what I think this doesn't address is a central terminal on North and on South Campus. There's only a central terminal on Central Campus, so I would have liked to go back in and design maybe another larger bus stop on South Campus, which would be where they'd be serviced. So that could be something that I'll go back in and design.
Yeah, I think that. I mean, I think just sort of acknowledging those issues helps a lot, because again, for if there's a transit company or a certain university or whatever looking at this sort of thing, that's always one of their concerns is how does the maintenance work, where does it happen, where's the equipment for that.
Can you tell us a little bit more about your overall process that you took?
Yeah, so everything always begins with a sketch. Once the idea is there, and after inspiration and research diligently done, it begins with a sketch. And then as that becomes more detailed, it'll then go into Rhino. And all of these CADs are actually all Rhino files. So there's a Rhino file for the climate control, for, the transit hub. There's a Rhino file. If anyone doesn't know what Rhino is, it's Rhinoceros 3D CAD program. This is all one large Rhino file, and once I build the shapes, I then import them into KeyShot. And based on how I layer my shapes within Rhino, I can assign different textures and colors. And then from there, this presentation was made in InDesign.
So back to your process, you solved for multiple problems at one time. It was a question of efficient use of the street, because you talked about overlapping routes, you talked about shelter from climate. Why did you choose to take on the problem in its most complex state and not just solve for one thing?
So as a senior, I have a thesis, part of the curriculum at the School of Art and Design, and this was an idea that I had for that thesis project. But just with the timing of grad school applications being in January, I wanted one project that would be the highlight within that portfolio. So that was the reasoning as to why I did this at that scale, hopefully to try to get get acceptances. But yeah, mostly for grad school.
Would you see this having kind of wider application besides just, you know, this this particular setting? I mean, it seems like you almost designed a set of fairly universal pieces, but then applied them in a very specific location.
Yeah, I think it could be used on any university campus of that size. I can immediately think of the University of Florida, any big state school, Syracuse, Ohio State, Michigan State University, or any really institution that needs to move large numbers of people outside of the university setting. I did look at a lot of bus rapid transit systems, so the one in Bogota, Colombia, which is the largest one in the world. So really any city, or excuse me, bus rapid transit systems have been used a lot in cities, so I just wanted to kind of modernize that, and yeah, I do think that it could be used.
And would you see this as dedicated lanes, like BRT systems?
Yeah.
I wondered about the glass too, because in winter, when there's that much white, it's almost blinding.
Mm-hmm.
To then be further in a highly transparent, reflective environment, I'm just wondering how that translates.
Well, so the glass wouldn't be that transparent. The transparency in the renderings was just to show the interior, but I could imagine, this is all conceptual, so I could imagine that in maybe 20 years there's a function like in 787s now where you can dim your glass. So maybe that is something that is used.
At what point did you decide to go the driverless route, and why?
I decided to go to the driverless route almost instantly. The University of Michigan on North Campus houses one of the biggest university-level autonomous research at M-City. And so because this image is actually North Campus, I wanted it to speak to kind of the local autonomous research that's going on within the University of Michigan. So that was almost instant.
Could it work with driver vehicles as well?
Yeah, because the current system does have driver vehicles.
And do students, is it free to students to ride it, or do they, so it just gets funded through tuition?
Mm-hmm.
Are there things that students have done to kind of like augment the current system? Like, is there a lot of usage of scooters or bikes, or do they kind of have this mixed sort of modality when it comes to transportation?
Yeah, well, students can input their own feedback through a survey that they have online, but there are a number of scooters, as we've seen kind of in New York City, Birds and Limes. And along some of the bus stops, not all of them, there will be bike racks, but they're not actually implemented within the bus stop. So kind of last mile would be maybe Uber, Lyft, and then scooter and bike, if not walking. But during the winter, everyone just braves the elements, because if you get on the bike, chances are you might fall.
Yeah. Did you consider systems for bringing the bikes on the buses?
So actually the current buses do not allow bikes to go on.
Yeah.
And with that interior row, they would only fit within the door space. So what I envisioned the bikes to be would be from that bus stop, from that transit hub or the Central Campus Transit Terminal, outside to the outskirts. So it would go to a home. You'd be essentially riding it to the bus. You wouldn't have to take it onto the bus.
Yeah, at Google we have shuttles. I live up in the city and I commute 40 miles south from the peninsula, and we put our bikes on the outside of the bus on like a bike rack.
That's cool.
Yeah.
Yeah, there's some cities, I know
Mounted to the front, yeah.
I know Providence, Rhode Island has a system like that. There are a few other cities that do that. They have a big bike rack that sits on the front of the bus.
One more comment before we wrap up for the next group, anyone?
No, any comments from other students?
Have you, during your research process, have you identified any insights that can apply to multiple communities, not only within Michigan, any insight that you identify that maybe can apply to can other universities can utilize as well within the transit system?
A lot of the research that I was doing was really based on the University of Michigan and our local geography. As to what can apply to other universities, I'd have to think. Can I get back to you?
Let's go ahead. Love your presentation, great. I was just wondering as to how your time management was into putting forth this, because everything's pretty good from what I say. I'm only a junior in college, so from what I'm looking at right now, it's actually pretty spot on, and I got a lot of inspiration from it. So how were you able to do some time management to put forth this type of presentation together, since you worked on it by yourself?
Yeah, well, thanks. I appreciate it. Just non-stop, it's a grind. There's no other way to say it.
He has no life. It's
But setting weekly deadlines was something that I did. I want to have the sketch done by then. I want to have the CAD done by then, just to try to meet a further out deadline.
Okay, so you set a certain time for yourself that at the end of the day or the beginning of the day that you will work on this project for this amount of time, and then you carry it on?
No, not even that. I just look at my calendar and I say, by this Friday I want that done, by that Friday I want that done, and then I'll allow myself to do whatever I want. I don't schedule my time. But as long as it's done by Friday, however it's planned.
Okay.
Thank you.
great. Thank you.
Excellent. I'd like to thank you, Emmanuel. Thank you, everyone. I think the grind is going to be something that's part of your lives as you grow into full-fledged designers. So I wanted to go ahead and invite the group from Harvard University, and their project is the jet stream catcher, and we have one representative from that group. So come on.
Hi everyone. We are a group of students from Harvard, and my name is Yujie Wang. I have a background in architecture, design engineering, and energy systems.
I'm Adolphus, and our teammate, our colleague Tianwei is unable to come today, so we will start.
So today there are lots of discussion about urban mobility. So when we look at the problem of mobility, we try to define mobility from a wider perspective. So there are energy mobility, information mobility, social mobility. And in this challenge, we are particularly interested in the future energy mobility. And the human development in tandem with the anthropocentric reliance of fossil fuels has led to huge negative impacts on our planet and caused climate change. And here is a scene of Canadian tar sands mining. You can see it has detrimental damage to the earth and the plant and the landscape. And you can search tons of images showing how these fossil fuels-based operation lead to damage to our planet. And there are lots of scientific research. For example, this one by Intergovernmental Panel on Climate Change. It gives us some proof on our anthropocentric agents that cause the greenhouse gas emission. And in 2016, the Paris Agreement, different countries signed international nationally determined contributions, but actually the result is quite not optimistic, because based on different simulation, different scenarios, it's very hard to reach the targeted objective to control the temperature raise within 1.5 to 2 degrees by 2030. So there's a huge demand for energy system transformation, especially from the fossil fuel-based energy production to more sustainable energy system. So our idea is the jet stream culture. And jet stream culture rethinks the idea of energy production and transportation. And today there are lots of efforts, for example, to increase energy efficiency, to mitigate the current environmental impacts, and there are also transformation of previous fossil fuel-based industry into carbon-free, carbon-free operation. And we are giving an alternative solution, and we design a future energy infrastructure with an untapped sustainable energy source, and it tackles the problem of energy mobility. And we start looking at the atmosphere layers, because most of our labs are within the troposphere. But actually the planet and the atmosphere has a much wider scope, and there are stratosphere, mesosphere, thermosphere, and they go. So the height, the altitude we live within is actually a very small amount of the whole atmosphere. And we see some interesting projects. For example, this one launched by Google X, the Project Loon. It is a network of balloons traveling 20 kilometers up in the stratosphere, delivering internet connectivity to people in unreserved and underreserved communities, especially in developing countries. And the idea of jet stream culture actually comes from one of my terrestrial energy system class, and the professor introduced the jet stream zone. Jet stream zone is at the intersection of the atmospheric circulation cells of our atmosphere, and the air, due to the Coriolis force, there forms a partial pressure difference, and form this consistent wind band, and it is called a jet stream. And there are polar jet stream and which are the strongest jet stream at the height of 9 to 12 kilometers, and there are also subtropical jet streams shown in shallow gray in the diagram, which are within the 10 to 16 kilometers. And we find there's opportunity to utilize this untapped energy system energy source, and because there are lots of large cities within that jet stream zones. For example, in this case, we take Toronto as a sample city, and locates within the polar jet stream zone. And there's a comparison of the conventional wind turbine and the one that could be powered by jet stream. The conventional wind turbines around 8 miles per hour, and it's a low efficiency with intermittent wind. But when it comes to jet stream, there will be 100 miles per hour, high efficient generation with consistent wind. And we also look at the wind turbine technology development today. Right now, the largest radius of the wind turbine goes to 120 meters. And so we are proposing this. We treat this project as a speculative design, and we design beyond the latest capabilities because we want to push the possibilities further. And this is the gyrocopter in the jet stream zones. We propose that generate power with this vertical wind turbine, and it's balanced by the quadcopter mechanism of the main structure, and we try to map out this energy flow diagram, the system energy flow, where the energy captured by the gyrocopter, which is the mix of generator and quadcopter, are captured by the gyrocopter, and then part of the energy was for self-sufficient balancing issues for the generator itself, and then the other energy could be transferred by small quadcopters, and the small quadcopters function as energy carrier, and they discharge this energy on the energy hub, which is the ground infrastructure part, and so the energy hub distributed the stored energy from the energy carrier, and distribute that to electrical vehicles and smart grid system in the city. And so on the right side there is a diagram shows the structure in the more physical conditions. It combines the jet stream capture system combines the drone technology with the wind harvesting techniques. There are 3 parts, with the gyrocopter harnessing the energy in the jet stream zones, the small quadcopters transferring the energy into the energy hub, and then the energy hub produce energy into to electrical vehicles and the smart grid systems. So the small quadcopter could get charged by plugging in at the bottom of the gyrocopter, and then transferring through the atmosphere. And here actually the selection of the small quadcopter as an energy carrier is through a few comparison with the proposed ideas. In one proposal, we're trying to look at this radioactive and transmit the energy by electromagnetic field, but we think there may be a large scale risk for society, because this kind of radioactivity would cover the entire city. So we choose the small quadcopter as the energy carrier, and the small quadcopter will land on the platform of the energy hub and discharge energy for electrical vehicles charging. And here's a rendering of the energy hub. The spiral form comes from the geometric metaphor of the vertical spiral turbine, and it not only creates this formal consistency, but also it could integrate into the current road network. For example, the energy hub could be located at the roundabouts in the city, and these the pochette parts, which are the dark gray parts, are the energy mass, which will store the energy that get transferred from the gyrocopter. And in a section, we can see the energy hub structure has a possibility to integrate with vertical urban mobility and to charge or discharge, charge the subway system. And we see there are more possibility with this kind of system.
Yeah, so I know it's about time. I will just keep it very short. So I want to talk about the perspectives of our design. So I think that in the age right now, because energy is so carries so much economic value, so in the most prosperous urban regions such as New York, they are very rich but it's actually that we need to have the mind of international development when we design. So even in the latest design, this is Hong Kong, the Greater Bay region, it seems that the current governance the current development is only empowered by functional-led regions. So I think that is not enough. Because the current environmental governance is almost incremental and led by this very purpose. And in fact, there are a lot of sources of energy if we talk about energy in the sense of an anthropogenic angle. So actually through the technologies in the applications, through the design of technologies and design engineering, we can bring a lot of chances to rebalance the energy within the Earth. And this is one example in China where they use the drones. E-commerce companies use drones to deliver agricultural products in the rural regions. And also in our age, because like 5G and the smart city, we have a lot of data centers, so we need to keep in mind that even we have the energy redistributed, rebalanced, we need to have more sources of sustainable energy, like what we discussed. And so we believe that with the design, we can create new energy and new mobility, which will enhance then the social mobility and less externality, and new global governance. So this will, lead to a better future. That's what we believe. Okay. Thank you. Thank you.
Tell me a little bit more about what's happening at the centers where people kind of can come. You showed an example of somebody charging a car, but sort of what would you imagine the types of activities or the what would be the experience like if I came to one of these places?
Yeah. So we have this vertical core with these elevators from the subway layer to the top of this. We call it the grand stairs, because we not only want to make this energy distribution structure, but also it could be a urbanistic interface for people-city interaction. And this form making of take the metaphor of a spiral wind turbine. It's actually we want to visualize the invisible wind, and we want to create this as a symbol of sustainability that can raise the public awareness of clean energy use. And so we imagine there could be greenery on the platform. So it's not just a cold energy mass, but kind of a public activities platform, and people can participate in this process and promote this kind of energy mobility in the future. Yeah.
I think it's a really sort of intriguing idea. I'm not convinced by the physics of it, because I think that wind turbines work by being anchored to the ground.
Yeah.
As soon as you have a wind turbine that's in the air and the wind pushes against it and turns the turbine, then the thing that's holding it there is pushing back, and you're using as much energy just to keep the thing up as you are generating. But putting that aside for the moment, what makes this a better system than the conventional methods of generating and distributing energy now?
Yeah, because we try to approach this problem from a different way. Instead of like increase the efficiency of current system, we want to incorporate like more energy sources. It's kind of provide alternative thinking to this problem, and we understand there are like physical constraints. For example, how to like stabilize the jet copter in the jet stream zone, and there are certain technology. There are some wind net, but there must be lots of challenges. But here, I think as a speculative project, one of our motivations is to inspire more researchers and designers to look at this problem like out of the conventional box, and so it's kind of our vision for the future, but it may not take the form as this one. It's kind of a step forward to that future.
Yeah, I mean, personally, I would find it more convincing if you weren't trying to fly this thing, just build a structure that's super tall, because that's something we know how to do, and can be done, and it's true that you get more wind the higher you go, and so there's a logic to it that doesn't have all of the challenges that you sort of set yourself up for by having this thing sort of being flying.
Yeah, because in terms of that, we actually have a decision making on this issue, because firstly, like building a like large, for example, foundation structure may be an ideal solution to stabilize. But we also realize the jet stream is not actually stabilized within that belt. It moves with the Earth's revolution around the sun. So it will move north and southern, like quite a wide range. So we are thinking about the in a global scale, the gyrocopter would not be like nationally owned, but like more like global shared energy producer. So the city within the belt at that time could benefit from this energy infrastructure. Yeah, and the ground energy hub could be a fixed location. So that's something I did mention when it comes to the jet stream.
I don't know much. I know that Google has a project where they are using wind kites to, it's called Makani, and there's something about, I don't know the numbers, but they're like 80% less expensive than the big wind turbines, and I guess that's a big problem with them. But these kites, they sort of look like a T-shaped thing that goes up very high, and they sort of spin around, and they generate a bunch of, they harvest a lot of power that way.
Are they tethered? Is that what
They are tethered, yes, yeah. But I don't know much about them. But it is interesting. I know you referenced Loon here, which is also another kind of aspirational sort of, farther looking out. But it's actually, like you said, in use today. And your project reminded me of the Makani project as well. So maybe check that one out.
Yeah, thank you. We'll check out. And because the Makani energy cats actually they are using like the normal wind energy in the atmosphere, Yeah, here we are especially like want to push this forward, and there are like, huge energy existing in the jet stream, but currently there are like less research and development in this area. So yeah, we want to raise this awareness and yeah, kind of into the future.
And-
Time
yeah.
for more question.
So in best case scenario,
Mhm.
how many of these would be in each city?
For the
Are you
For
planning
every-
like one per city or?
I think for the like downtown area, especially the area that is the highest energy use, because we designed this to locate at like roundabout and kind of like high density urban area for this part, and it's definitely not economic for like suburban areas because there are like more energy transmission loss during that process. So I think like 1 or 2 in the downtown area would be like reasonable.
It just
number,
seems for that, if you're thinking about in a high population area,
Mhm.
space is already an issue, and so then
Mhm.
the scale of this
Mhm.
and the footprint of this
Mhm.
and how much it disrupts the landscape in
Mhm.
general. Is there a more efficient way to
Mhm.
solve it where the scale of this is not at the level that
Mhm.
you have it at?
Yeah, these are some problem we need to think for, because mega structure is not like that into a human scale, not perceived as a friendly build structure. So yeah, maybe we think of like decentralized like smaller structure. Yeah, could be a like good idea to move forward. Yeah.
Thank you.
Thanks.
Okay, I like that we're thinking big here. So next I want to invite the University of Washington, who are going to present on their supply chain design project. So welcome.
Good afternoon, ladies and gentlemen. We're from the University of Washington. My name is Ian.
My name is Sarah.
I'm Claire.
I'm Cecilia.
And I'm Sarah.
And today we're here to talk about the supply chain alert system to imagine the future of food transportation. My favorite food is barbecue chicken. It's so crunchy and so delicious. But have you ever wondered one question? How did that chicken get into your plate? Where did it come from? Let's take a look at a deeper dive on where the barbecue chicken ended up in your plate. It usually starts off in some kind of farm where the chicken is raised, then sent it to a manufacturer where the chicken was being prepared and processed. Then it crossed a long way, eventually arrived at your local retail store. What we just look at there is what we call the supply chain. Supply chain is a model of how currently customer goods are transported within each countries. Overarching what's called the food supply chain, what we call the regulatory agency, such as USDA, they monitor every step of the way to ensure your food is safe and sound. However, today, we're going to scale down our scope a little bit to only talk about the distributor and retailer portion. And I'm going to hand over to Sarah to talk about why we scaled down to that scope.
Okay, so it is estimated that meals in the United States travel about 1,500 miles to get from farm to plate. So we're in New York City today. That would be like us hopping in a car, driving all the way to Nebraska just to get that piece of barbecue chicken. It's a very long distance. So 12% of food is lost during distribution, mainly due to improper refrigeration. So this is where we wanted to really narrow down the scope of our research to focus more on temperature and location in order to prevent food safety hazards and help mitigate waste during the distribution process. Because as Ian was mentioning, along the supply chain, there's all these points in between where the food is going from farm to a processing center, it's getting off the truck, maybe sitting in the sun for a while. The temperature can actually get outside of this food safety zone, but that isn't accounted for when the next processing center picks up that piece of chicken, because when it's in the trunk, the temperature can actually go back to a normal safe level. So it's really hard in the current model we have today to really account for what temperature the food is at along the entire journey. So based on this, we really wanted to ask ourselves the question, how might we create a system that ensures food safety requirements are met during transportation points in the supply chain? For our research areas, we did a lot of secondary research to scope down exactly what comprises the supply chain, what regulatory agencies are involved. So there's the FDA, there's the USDA, they each manage different sections of the supply chain, and they target their inspections in different ways. So some ways they target inspections are random, based on like being notified of a potential food hazard, but there's not really a way currently in place for the data to be transferred between all these complex agencies to have more targeted food safety inspections. We also researched into existing technologies, so we wanted to see what sensors exist today in terms of monitoring temperatures, and then also looked at the infrastructure of the trucks to see how the temperature is controlled in the units, how it's monitored, and learned that a lot of the data transfer that happens along the supply chain is based in paper format, and so records can easily be lost, or things can happen due to human error, or even an inspector accidentally missing a shift. There's like a lot of moving parts in this whole complicated system. And then lastly, we investigated food safety hazards. So what hazards exist today in the current system, and then how this design could help mitigate the loss of food. And then I'm going to hand it over to Claire, who's going to address the insights that we derived from our research.
So based on the research Sarah just talked about, to help us inform our product that we designed, we created 4 insights. So the first insight is temperature and location tracking of food needs to be accurate, constant, and real time. Secondly, users of this product should be able to make the final decision based on presented data. Third, respondents in the supply chain should be immediately notified of potential food hazards to prevent food safety violations and mitigate waste. And lastly, data should be transparent and constantly shared between supply chain sectors and regulatory agencies. When we made these, we actually made a few design assumptions that we want to address. First of all, we're assuming that the transfer of data would be reliable and transparent. So we're kind of assuming that this trust is embedded into the system already, and no sector will be fabricating data that they input into the system. And also, like Sarah was saying, the technology that we looked into, we're assuming is existing in the system as well. So, for example, like to account for paper data being tracked, we could look into systems like blockchain, which could create a way to share data live and right away, and then also like RFID chips and other sensors that could be used in trucks.
Yeah. So we present you the supply chain alert system. I think the magic of our design is our design required less human intervention along the supply chain, make a larger impact. And here's the conceptual model of our design. Our design is backed up with a database. Our database with a built-in function called a data reference. A data reference, every time it detects a normal behavior within the data set or detect a pattern, it will immediately send a warning to USDA and the next person in line. The next sector in line, when they receive the warning, they can take action immediately, where the USDA can keep track of the record, so for future data referencing. Now we're going to talk a little more of our featured interfaces.
So for starters, we wanted to look at what the user would see from a holistic viewpoint. So starting from the state view, opening the interface, they're presented with kind of clusters of where different trucks would be located. And to ensure that they're not overwhelmed with information, we have them clumped together into numbers of that various area. And this just ties into like our first insight of having that like real-time information readily available. So when you zoom into city view, you can finally see like those trucks and the direction that they're moving along the route.
So, however, when there is an abnormality in temperature detected by the system will first alert the users, send a warning, and also it will highlight the incident of the truck over there so that the users could know the exact location of the specific truck so that they can easily locate it. And also the users can click the view to see more detail of the information of the incident so that they can make judgment as well as their actions according to the information they have. However, we acknowledge that there could be instances when there are multiple alerts happening at the same time. So at that time, our system will list all the incidents based on the emergency of it. For example, it will judge how much time of response the users have, and also the economic cost of this specific incident, so that the users know kind of what incident is more important to solve first, and they can make judgment based on that.
So in the case that food contamination is detected as a potential threat, the system is able to provide recommendations about how to reroute the truck to avoid that threat. So the red path is showing the original path that the truck is originally intending to take, and how if they go along that path, they may run into the risk of food contamination. So the system provides the green path, which is showing if you take this path instead, you will be able to avoid this risk of food contamination. And the system is also able to provide the data and explain why it's making these suggestions for you. So it's able to detect patterns in the data and interpret them in a way that makes sense for the user. So for example, there's a high financial risk if action is not taken, and you're able to see more of that data behind that suggestion. And overall, the system provides the data that helps the user make a more informed decision whether or not they want to go ahead and reroute the truck or if they want to ignore the suggestion, and ultimately make the decision for themselves. And in the case that the user does want to reroute the truck and to avoid that risk, the truck driver is automatically and immediately notified so that they can take action. And the next in line in the food sector, so in this case the processing center, there's also an option to notify them as well.
So what's next? We would like to further polish our interface. We would like to do some user testing along each sector of the supply chain to kind of understand the needs of the users. Furthermore, I think even though our scope is only between the distributor and retailers, it gives us a peek of the future, what it's going to look like when it applied across the supply chain. Even overall, we're going to develop interface for regulatory agencies. The power of that is that regulatory agencies collect all these data. They will be able to collect patterns and trends. They can even predict food hazard happening beforehand based on the past data they have. And they can target and specify their inspections to target towards specific companies based on the data record they have. And thank you for having us, and we're now open for questions.
I really like your overall narrative, the problem statement, and how you talked about the insights you developed and how that informed your design. So that was very nice. What I think is also interesting too is what you talked about at the end, how you could begin to sort of use this data over time. And so instead of trying, are there routes, for example, that make more sense for certain types of food? I don't know how distributors work today, but maybe even bundling certain types of different deliveries together to sort of, I'm sure they probably do something like that, but just basically trying to learn from that data over time and uncover those patterns, I think would be really, really kind of interesting.
Yeah. I think we identified two main users within our system. One is being the USDA or regulatory agency. Another is those who are in the supply chain. For the user who are in the supply chain, they actually need quick action, right? Like really small scope of action they needed. They don't need to know the overall trend, overall data of how the supply chain is shifting. Where the USDA, that data will be really useful for them. So we believe that different respondent or different users should cater different data that's best for their use. What we're showing here today is the kind of the supply chain sector and the user within, but we would like to expand further into the regulatory agency. We think that's really powerful.
Yeah, we think that the regulatory agencies is one of the biggest applications because with the USDA and the FDA right now, they each control really specific sectors, like let's say frozen meat, for example, or like another kind of product. And how they perform inspections, it's so randomized that if there was a way that you could see not only when a food hazard happened, but when it potentially happened, so for instance, if one truck, we could pinpoint that truck has a problem with its cooling system faster, that could be added to the pattern that the FDA or the USDA could receive, so it kind of builds this chart over time that shows this place has had 25 instances of potential food hazards, or this place should be inspected right away because it has chosen to ignore the risk of a potential food hazard and not reroute the truck multiple times. So it would save their resources as well to be able to pinpoint where to target.
I also really appreciated the clarity in your presentation and the definition of the problem and your process and your research and how you qualified certain assumptions. You seem to be mostly focused on temperature of food as a thing, but certainly when regulatory agencies are doing inspections, they're looking at things other than temperature. Have you thought about, are there other things that could be expanded, that could be done?
Yeah, so we were thinking that temperature could kind of serve as like a base level for investigation because it's easily traceable and something that is like so constantly shifting versus like testing the actual product in like a lab study would be a little bit more intensive. But if they're aware that a certain firm has a problem with food safety hazards, they could maybe target their inspections, which are based more like on going into lab studies for those specific firms.
Adding on to that, I think we identify like 3 categories of hazard that potential can happen. It's chemical hazard, biohazard, and human error. However, if we explain all that to you all, the project will be super complex.
Yeah.
For the project clarity and how kind of like the idea kicking off the idea start, we kind of narrowed down to what's mostly happened was the refrigeration system. We pinpoint that 12% is lost because of that. So we think it's really important to kind of pick that point out and kind of explain how that system is going to work and then expand in the future to all those areas.
So I think it's a really good starting point and a good base, and it makes a lot of sense why I did that. I just think that from a regulatory agency perspective, it'd say, okay, this system is going to save me money because it's going to save an inspector going to check on something, right? If the inspector has to go and check on stuff anyway, because all you're doing is looking at temperature, it's less value to them. So I think that's something for you guys to think about going forward. And in general, it would be interesting to sort of think about the economics of this. Like, it's a great system. Would be great if it was in place, but who's going to pay for it? Like, does it save money? Does it add value? So things like that, I think, would really help to sort of flesh this out a little bit more.
Yeah, like how would you incentivize these different distributors to use it instead of having to think of it as a top-down sort of mandatory thing?
Yeah, if you could do the analysis that shows that the distribution company has to throw away this amount of food and that costs them this much, but your system is actually going to save that money and then pay for itself, something like that.
That's actually an interesting point because we did do a primary interview with someone in the supply chain who said that they have these like current monitors that if, for instance, a package of fish is spoiled, it will like turn a specific color to indicate it should be thrown away. But the benefit of this system would be rerouted, so you wouldn't lose all the product.
Right.
I heard a person we interviewed, he kind of said that each sensor is kind of expensive to implement, so they will only use those kind of sensor on expensive products. So we are thinking about like when we are designing, we also want to consider about the technology constraint. So we think in the future those kind of things will be cheaper to imply into like our system.
Another good point I think we can mention is going back to the supply chain model. We believe the customer is the one who actually drives this entire chain. Even though we view it as this way, but we believe the customer have really the down effect on the entire chain.
Right.
So if we do education on a customer and customer is more aware of the food safety, if they make economic choice on what product are buying, what product are not buying, that will incentivize company to open up their data to kind of collaborate within, because ultimately the customer is the one that making the purchase, and that will impact the entire economics of the chain.
I would say the other thing again, and this is my bias as someone who's involved in the sort of physical world of design. I really want to know what this thing looks like. What is the sensor? Like, does it sit on each package? Does it sit on each truck? Like what and I think that would, even if it's just a conceptual idea, what it look like, it just helps make it realer in your presentation.
Yeah, the storytelling was really great and clear, so I understood that. But there were moments, I think, where I lost who the user was, because you started very much from the place of what you like, and so even now I'm sort of trying to figure out what will the consumer actually see, and how much data will I get on a package of chicken, and do I really want to read all of that? We're already overwhelmed with labels these days. There's nutritional information, there's expiration dates, there's manufacturing, there's hormones, no hormones, it's, did it eat grass, not eat grass. That in addition to that, if you're going to check on during its lifespan every temperature it encountered, for a consumer that feels very overwhelming. The other thing that also struck me was there seems to sort of be a disconnect between the layers of information, because if a larger agency like the USDA were using this interface, you present it at a macro level where you can see that there are 16 trucks in this area, but you're actually problem solving on a per truck basis. So when you do that macro view, you have to really dig deep down to actually find your problem. So it is in some sense causing error, because you could miss something if you don't distill down. So there has to be a way to find the problem at a macro stage and then distill down. And that was what I was missing in the interface, was how do you find the problem at a large scale, and then, because the only way I saw it was that when a single truck highlighted red, you knew that was a problem. How do you do that when you're tracking on a global level or even a regional level? That's a lot of data to sift through to identify a unique problem. So that kind of scalability of problem solving, I think, still needs a little bit of adjustment.
I really like that you spoke to the consumer and what information they receive. And I think that with the future of augmented reality and our ability to scan products in the store, increasing data transparency could be really valuable for a consumer, because I do believe that we vote with our dollar. And so by choosing a company that has had a certain line of, transparency with this product and sustainability and all these other factors could make a huge impact on the global food supply chain.
I think this is where I think you can make an interesting connection, as he was talking about economy, where if a brand were to invest in that kind of research, I'm more likely to trust a brand than to stand at that grocery store and do that level of inquiry on the
But it's
spot,
like
right?
I don't know if you guys know, but in New York, the restaurants all get graded, and so they're required to post that letter grade in their window when you walk in, and it's simple like A, B, C, D, and no one eats at a C restaurant, right? It's just like you just don't, and so that that really helps. That harnesses what you were talking about in terms of the consumer decision on it. So I do think there's a way to sort of boil down the information to something that's very consumer friendly.
But a data dump on a consumer at the time of purchase feels a bit intense, to be honest. Yeah.
I think just to quickly clarify, I think a lot of the question was raised in terms of FDA. We actually haven't fleshed out the interface. I think if we presented interface, that would make a lot more sense. We did think about how can they get down to the bottom data and what they can look how filter the data for them. Because one of our professors actually always tell us is that in this stage, information is not scarce. It's human attention. And how do you catch the attention at the right time? How do you cater the information the user need at the time? It's kind of what the magic of our design. And we do believe if we polish the FDA, the regulatory agency interface, the whole system will make way more sense of how we present it. And we'll definitely work with ID designers to kind of implement this chip, kind of figure out how it's gonna look. Yeah.
Thank you.
Thank you so much.
Excellent. So I wanted to introduce Sarah Williams, who's literally fresh off the airplane and teaching a class and getting on a plane and being delayed. This is Sarah Williams. I gave your bio earlier, Sarah.
You gave my bio earlier.
Yeah, so everyone's familiar with
literally off a plane. I felt like it was gonna fall out of the sky because of the wind.
Oh no, I'm sorry. We had an Airstream presentation earlier that might have been informative for you.
Sounds interesting.
So thank you, University of Washington. I will definitely pause next time I'm offered chicken until some design version of your design is implemented. But I want to introduce actually what we consider a local university, Kane University, is presenting their journey map. So welcome to the stage.
Hey, good afternoon, everybody. My name is Michael Daniel.
I'm James Durazio.
John Almeida.
Leo Torres.
We're from King University, Michael Graves College. So what we have brought to you guys here today is the future of university transit system. It's a little bit of a boost from the journey map.
Okay. So, hello everyone. I just wanted to speak on why we did this. I want to explain why we chose to do this problem. As you know, we're 4 college students. 2 of us dorm and 2 of us commute. So we know the struggles of everyday college students from not just from Kane University, but from across the country and the globe. The troubles of the commute is that there's traffic, you have to get out of your house, you have to park your car, you have to take the train, there's train delays, you're going to be late to class, you're going to have to tell your professor, sadly. Dorming is not as good as it seems. You have to wake up, you have to go eat, you have to go brush your teeth, you have to walk to class, and imagine in this weather it's brutal. Trolleys are always late, there's no biking system. So why did we do this? We did this because we want to make a better system, not only for us as the users, but also for the faculty. And I think this system could be implemented not only at Kane University, but could be implemented in other campuses and other universities, and maybe even on a bigger scale as part of a bigger ecosystem.
So as John just stated, the problem that we face is train delays, other commuter delays, if there's accidents on the road. Anyone has to put up with that, not just Kane students. So anyone who lives in a densely populated area is going to be going through the same situation that we are. This is just a quick example of a day in the life scenario for someone who's traveling to Kane University. To start off, student A is getting ready to board the light rail system at their local train station. So they have to go from there to the next big hub train station, which for us would be Newark Penn Station. And from there, they have to transfer again to the next train that brings them to Union Station, which is on campus. Now, after arriving to the university, the students will walk from the station through main campus to their class, which is located on East Campus. Now, for anyone who doesn't know how our school is set up, main campus and East Campus, the furthest points are probably about half-mile distance. So that's a decent walk, especially outside in the cold. So you have to walk from the main campus all the way over to where you arrive at your class on East Campus.
We came up with a solution for these 4 points as to how to make sure the students and faculty can get to the campus more efficiently in time. For student B, they will go to, let's say, the North Penn Station, and there will be a section off just for that student or faculty member to get onto that bus, which is an autonomous bus. They will have to put in their ID or show that they're a Kane student in some way or form. And same thing with the faculty, that they flash an ID and scan their way onto the bus. The bus is autonomous just to fit in for a moderate reason, because we're moving more technologically into the future. And as ID majors, we were trained to show that we're to be most advanced but yet acceptable. So even though these buses are going to be autonomous, they're also going to be run by a human driver, operator of some sort. It's just only keep track to make sure that the bus is running on schedule and everything. Problems can happen. They can switch and move over to manual and just continue on to the schedule. The buses are going to be timed onto the time sequence that the college has offered. So as they're going from the train to the bus onto campus, they'll drive over into main campus, which is 2. When they get onto 2, the bus would take them over to the main campus, and then they ride into 3. 3 is basically giving you 2 choices as to how you want to get around the campus. You can either A, take a bike, which is you can register from your phone, or C, 2, my bad, is to get a cart. A cart can hold numerous amount of people. It's almost like an Uber, but it's not. It's only for to take you to only the main places in the campus. So only certain buildings as to what class you have to go to, and each car will only go to that said building. And then 4 will be that they chose that they take the autonomous cart, and then the autonomous car would just go back to another place, and they would just go on throughout the day. This is a 24/7 service because most of the classes don't get out until 10:45 at night. So this is a constantly moving thing that makes sure everyone gets home safely and gets to their classes orderly and on time.
All right, so first things first, I will say that everything here is conceptual, and there are also 4 parts to this. So you're going to start with the bus, the cart, the bike, and the application. And the application itself ties everything together. So first, start off with the bus. How it's set up is like an electric vehicle. So it's an aluminum body chassis, 4 independent electric motors. It's equipped with a 440 kilowatt-hour battery, which is floor mounted, which gives it about 250 miles of range. Electric power steering. Of course, throughout the body of itself, will be embedded cameras, and then of course embedded long-range sonar sensors and radars. So in terms of for autonomous, we want to make sure it's safe. And of course, because we're in the 5G section now, we decided 5G is going to be the best in order for this to continue with autonomous. And in terms of how we said it's kind of like Uber. Through the application itself, you'll be able to see live where it is. Just like when you order an Uber, you will always see where the car comes from. So this is why we have a rooted GPS system. Now, how the interior works is, now since this is an autonomous vehicle, we decided, as students, there's never enough time to get work done, right? There's always another section. We still got to get things done. So we decided to have a classroom set up on the inside of this. It's more like a double-decker sized bus. So students can continue their productivity as they're on their way to classes. Now, where these stops are also set up is that every student lives in a neighboring town which is next to a city. So these stops will be mapped out along, especially for us students here at King University. We have students that are from different states. So we have Pennsylvania, New York, and New Jersey. That's just the minimum. Connecticut is also. So for students who live that far, it's really hard for them to commute. And as design students, we have late nights. You know, it's kind of hard to find your way back at home. So this is why we decided to go with this autonomous bus so that it can reach those areas and bring them back. And this is a rendering of the bus itself. Next is the cart. So the cart and the bus are pretty much similar. The difference is it's going to be smaller. So same thing, it's an electric vehicle, 4 independent motors, aluminum body chassis. This is because it's smaller, it's going to have a 425 kilowatt-hour battery, floor mounted, gives it about 190 miles of range. Electric power steering, like I said before, it will also have sonars and radars and cameras all around, autonomous vehicle, and routed GPS. Because for this, you can actually order this cart. So for instance, if you were to go to another, if you're on the route that the cart is coming, you can order it on the way so that the bus or the cart will know that you were there, and it'll stop and pick you up and go on through the entire route. And these are a couple renderings here. An environmental shot. And of course we have the bike. Now how the bike works, we decided, you know what, let's not do an autonomous bike. All right, let's slow it down a little bit, right? So we decided to do to exercise that comfortability of doing a pedal assist, so that students still continue that productivity around campus. Now these bike stations will be planted across the university on both campuses, so students have the ability to go on their own. On top of that, there's different colleges on each campus, so they'll be able to go to the neighboring college if they have to go to that. So this is equipped with 600 watt brushless electric motor, pedal assist, 36 volt 10 amp battery, which is located within the frame itself. So what you would do is you would walk up to this. You would actually have to take out your identification card, put it in because you're a King student, or you take your phone out because you have the application that will allow you to scan it on the screen, which is the bottom left is what I'm talking about here, and then from there you'll be able to use this electric bike to get onto your destinations, going to across campus, going to your respective classes, or going to your dorm rooms. This is the rendering shot here. Now what ties it all together is the application. Now you see at the application here, you would sign in with your Kane ID, and from there you would see live feed of where the buses are, and of course what the time frame is of the next bus if you are in those prospective cities or you're near those prospective cities. So that way you'll be able to know when and where the bus is coming. When you're on campus, you can see where the bike stations are and where the carts are in motion. You'll be able to reserve that bike or reserve that cart via Face ID, via Touch ID, whatever phone you use, you'll be able to get to that altogether. And this alone, the application, makes it a seamless experience so that students will be able to know what's happening at a live time. And that's one of the biggest things for us.
Another thing with the application is to help you plan ahead to manage your time and to make sure that everything goes on according to your plan. Because sometimes you have clubs and other stuff you have to go to because it's college students, you're trying to get the full experience of college. So with the app will also help you do so that we plan out throughout your day, so we have to do on campus and then we do off campus to help you get yourself off. So.
Thank you.
When you were thinking about your design of the buses, I think it's interesting that you have, they're autonomous buses, but it sounds like you have a driver or an operator there.
Mm-hmm.
And it looks like a traditional sort of, driver's, seat or station. Did you think about maybe changing sort of the orientation of that seat, or, to kind of maybe fit a little bit more with that role? So,
Yeah, okay. So, me and Micah were talking about this conceptual phase, and the way that we thought about it is the market. I don't think the market's ready for full autonomy. They're not ready, because I think the system could be implemented in just a few years, and that with this system is that once the market and autonomous vehicles become the norm, is that you could take out the driving assist and just go full autonomous. But as of right now, as of in the next few years, the market and the customers, especially the customers and the users, are just not ready for that. We don't want the pressure as college students, because it's all about the end user. We don't want the pressure them to get into these buses to get to campus, but we want to gain their trust. So we put a driver in there.
Also for manual override, just in case.
I can chime in on to this one. As I said earlier, as industrial designers, we have to make things advanced but yet most acceptable. So sometimes we have to like take baby steps in order to introduce a new product. Like how they're doing with the new smart cars with the Google cars, they introduce it into senior homes to drive them around little places. And even they have a little difficulties doing their things because sometimes they'll go off track and whatnot. So that's the whole point. I forget what the acronym was for. I think it was MAYA. Yeah, MAYA, most advanced yet acceptable. So if we follow that acronym to its fullest capacity, that's how we can introduce every advanced thing in a more smooth transition.
I like the kind of the aesthetics, the look and the feel of what you got. I think that that's very compelling, and I think does a nice job of sort of bridging between what's kind of recognizable and known and something that's a step into the future. I think that there's a, and it's interesting to sort of think about trying these integrated autonomous systems in a campus setting, because it's a fairly controlled setting, but it has also a microcosm of a problem that we have in cities at large, which is that classes start at the same time, everyone's going at the same time. So you need to be sure that if you're having all these people take all of these vehicles and like, is there space for them, right? It would be fine if they were sort of more staggered and going one at a time. But by kind of putting everyone into sort of smaller and smaller vehicles to get to their destination, then you have a lot of small vehicles arriving at the same time at a destination. You're just creating a traffic jam, at that point.
Definitely.
If I could chime into that one. We actually discussed as to how to make sure that doesn't happen. The way we discussed is to how it wasn't ethical, but still out there in the open because it hasn't even happened yet. So we decided just to have its own little transition, its own little road or rail to a set destination to go from point A to point B. To minimize the, we'll go to the rough sketch of the map real quick, if I can, over here. So this little station over here by one has a two-side drop-off, so to limit the congestion of it. One is the train station that's just way off the skirts that I didn't put in the train station.
I'm concerned with what happens at 4. Right? The rest of it's okay. It's at the end that
Yeah, but to eliminate that congestion is to have that rest stop for the buses to drop off the stair. From what I've noticed from most campuses, classes start at 8 o'clock, and the average commuter tries to get to campus at least an hour ahead of time. So, and that's pretty much more reasonable for the bus to be able to get everybody on there because the bus fits 32 people. So I say from what we had in the app that there was 5 places that we had labeled off, 5 places that fit 32 people. That would be more than enough to bring people, because those you have people that commute as well via car, and sometimes they would just choose to take their car or Uber to go.
Yeah, on campus, the buses, we have what we call a trolley system for us. It's cut in half. So we doubled it, so it'd be a lot more, it'd be easier for students to get in and out. And it's ride sharing, so it's on the way. It's still on that route as it goes. So we're just kind of going towards that route. Instead of it being a technical stop, the route is a stop at all times. You just kind of go up to that route and you just order it from there and stop.
And to finally touch up on what they said, we chose public transportation because the system really works. It's been out for years now, and it's efficient. It is efficient. It's just people don't want to use it. There's a certain stigma with public transportation. Oh, I gotta take New Jersey Transit bus to school? No thanks. The train, it's always congested. So we wanted to do public transportation because it works, and what this system theoretically would work. And to finally touch up on what they said is that lost my train of thought.
Is that we're trying our best to think ahead of the curve to eliminate these issues that could happen.
Right.
Is what we're trying to say.
Oh, I remember. So we weren't trying to eliminate other forms of transportation. We're not trying to eliminate people taking New Jersey Transit or taking their car and parking, but we're trying to relieve, the congestion that, you know, we're trying to leave parking because, you know, during the prime time of the day, during college hours, I mean, it is packed at Kane. There is nowhere to park. You can't park anywhere. There's like 5 cars going Mario Kart in the parking lot. And
That's true of any university that's
Any university.
city-based, you know? It's really hard to find parking.
So we're not trying to eliminate any other forms of transportation. We're just trying to add another layer to it and maybe improve the other forms of it as well.
So one other thing, it's a sort of design detail, but it's an important detail
Okay.
for you guys to remember. You have to think about accessibility. And if you show a bus that's got a bunch of steps getting up into it, it's going to be a problem. And it's a problem that, you know, as an architect, you struggle with all the time. You always have to be thinking about
For the
that.
cart, when I was designing the cart, I was thinking of that as well because I took architecture, so it's kind of the same motivations.
Yeah.
I was thinking that, you know, just, he even has it right here highlighted. I was thinking that like ramps could just like come out.
Oh, the
and
silver.
then come out with the silver, and then they could just board it. And I guess for the bus, Mikey.
The flooring.
Yeah, no, it's definitely a problem that can be solved.
Yeah.
And it's been solved, so it's, you know,
It's a minor detail.
I'm confident, it's a detail, I'm
Yeah.
confident you guys do it, but it's the
Yeah,
sort
we
of
did
thing that will, you know, that will jump out
Yeah,
to
of
someone.
course,
and-
yeah.
Yes, of course.
You have a question?
Yeah, it was just kind of a suggestion. I like the direction you're taking with your app, and I think there's something interesting about how you can enter in a student ID and how it's all about like optimizing student transportation, and that it could somehow potentially sync with a class schedule. So the app could know exactly where you need to be, or like a calendar, for instance, and like direct you to certain points of transportation, and it'll like constantly be updated, so you don't have to worry about like finding your way home, and there's more security.
This is version 1. we have thought about that
Yeah.
though, because in terms of when it comes to traffic, you know, you still might get late, right? So we were thinking, well, if the bus for some reason could let the professors know, well, these students are in this bus, and they'll say, well, they're coming late based on what's happening. There might be a traffic jam or something. So that's something that we did. We're thinking about implementing, but as it being V1, we didn't want to stretch it too far. But yeah.
Yeah. Really interesting project, guys.
Thank you.
Thanks for your graphics. They really help explain the bus. I think one thing that could help your presentation, if you're just thinking about it in the future, is some of these issues that you're talking about, like capacity, how many people come in, what do they use now, like some kind of visualization of that, because I don't have a sense of like how many people to ride the bus in now, like of the proportion of people commuting to this
For the
school.
bus, it's what, 32?
Yeah, 32.
No, I mean like on an
Oh,
average
on an
day.
average.
On an average day, you know, on an average day at Keene University, 100 people come from the bus, but 3,000 people come to Keene, right? Like, do you know what I mean? Like, and so,
I understand, yeah.
or
That's statistics.
or like, yeah, something like that. So like, okay, we have, you know, of 3,000 people that come to Keene every day, 2/3 of them are driving. We want to take the drivers off the road, like somehow to help us frame the problem, because I guess I'm not sure. Like, oh, is a bus? I mean, isn't there a bus already? Like, I like your bus, but I guess what I'm saying is like, how do you sell me on your bus versus the bus that exists already? So I want you to sell me on it, and I would say, oh, this bus is going to be better. It's going to reduce this many cars coming in, or people shift. Something else that could be fun if you guys are still pursuing it is like, think about, could you have some kind of crowdsourcing app that, because why do people choose to take a bus or drive their car? They like to drive their car because it's their own car, they can get
Their freedom.
home, like,
Yeah, it's a freedom.
there's like, so what kind of behavior change would allow them to move to a bus, right? Like, and it could be interesting to like you could have some kind of social media push to try to get people's opinion, like what would make you ride the bus, like, and you could have options, like.
So it's like a short survey still of what their opinion will be with the bus like. Because earlier we did mention that the bus is only exclusive to the members of the campus.
Yeah.
And you have to do your ID or put in like your schedule or something to show proof that you are attending, and it'll take you from point A to point B.
Yeah.
But that could be something that we could try to put
Yeah, because
into
you still wanna, if you're gonna have this bus, it's gonna cost money.
that too, yeah.
And so like, how do you know that you're gonna get riders on your bus, right? And so You want to make your bus design something that they want to be. So I like the desk.
Yeah,
That's
that's
great.
good.
That's great. But it'd be interesting to actually survey students to say like, what would make me ride the bus? And like maybe they say like, oh, they want to have Wi-Fi,
Okay.
or they want to have
Mhm.
something else that the bus might do for them that would make them switch from their car to the bus, right?
So to touch up on that, it's quite funny because in the research in the ideation phase, we actually talked about making you could rate your ride and you could add recommendations, but I kind of got lost in the flow of the process. But when you brought that up, it kind of we thought about that, but it kind of got lost in the whole process.
Yeah, we definitely took that into consideration.
I mean, you could think about too, like,
That would help
how
us
do you
out.
make it, how do you advertise it continuing, right? Because I think something that we always think about when we make something new in technology is we build it and people will just come. We forget that we have to actually
Yeah.
Convinced.
convince them that they want this thing. So like, why do they want this?
Yeah.
Is the desk gonna be enough, or does it need to be Wi-Fi and desk, or
Chargers,
Wireless charger.
charger? Yeah, you're already out of energy. Free energy. Or like something like the amount of rides that you get some kind of bonus at the cafeteria. I don't know. Like what
there's
is
a coffee bar. And
is there a coffee bar? Is there chocolate on the bus? I'm really hungry after class. There's a long class. No, but those kinds of things would be. I mean, I think like thinking about also like branding it.
Yeah.
Right? Because it's a blue bus now. I was thinking you have blue bus and you have the blue car.
Well, we did it based
and you
on
can-
colorway of our school.
Yeah.
But of course, we can always just throw a brand on it, throw the seal on it or something.
But you could imagine if like you had a name for the blue bus, like that's fun. People would,
Fun bus.
I don't know. Yeah, that might be like
Like a ring.
the chocolate. I don't know.
Excellent.
That doesn't sound right.
Sorry, I have to wrap up too, let's make sure we have time for next, but thank you everyone, thank you for
Awesome.
coming.
Thank you.
Answer this question before this again.
I'm advocating for kittens in the bus, because that will get me on that bus in a hot minute. So we have our
Bus, right?
final presentation, the air chair, and he's coming from Arizona State University. So let's welcome Paul to the stage. Like that?
That's good. Yeah. Thank you. All right. Good afternoon. I'm Paul House, and I'm from Arizona State University. And what's going on? Sorry. I can just hold it. sorry for the technical difficulties. I'm from Arizona State University, and shout out to Arizona State's Redesign School initiative. Go to redesign.school to see more. Okay, so today I'm going to talk to you about, I guess, a vision for mobility and a new way to address mobility specifically in commercial air travel. My product is the air chair. So I'll start with the issue that I looked into. I looked first at the elder population in the US and how it's growing, how it's been growing, and how how the elder population has increased in the US and how the rate at which they travel has also increased. Also, I've looked at how many, I also looked at the rate at which they have ambulatory needs. So as people get older, they tend to have more problems with motor skills or limited strength. And because of that, along with these other things, we can see that as the air traveling population gets older, they'll need more assistance. So that's where I started my research. I also looked at different wheelchairs in the airport that are used, and I just identified some issues, and I'll get into that later. So here's some of the stats I went into already, just showing the increasing elder population. I also talked about the frequency of travel. This is just the most recent data. You can see that most elderly people travel once or twice a year. And in addition to those stats, 6.1 people need different assistive devices to get around, and 1.7 million people need a scooter or a wheelchair to get around. So in addition to elders who could use this, more general public could use it as well if we address some issues. I went into the competitor analysis. The first two are the ones that are most used in airports. And these are pushed around by airport employees, and they start with this one that follows up the first one on the top left. And that one is used with usually a large pole attached to it so people can't fold it up and take it home with them. And then the second one is just a more robust and durable one, but it has some issues as well. Down below those two, there's the thinner boarding chairs, and that's used for people who can't get to their seat on the airplane. So lots of times people will be pushed to the airplane, and they can make it down the aisle because it's short enough. But in some cases, they need to be brought to the chair, like in these devices. Then there's some more expensive ones that most people won't invest in if they're just traveling once or twice a year. I then went to just mind map my ideas, just get some things out on paper, make sure I'm not missing any points. And I guess I looked mostly at just obstacles, physical challenges people will have, and then just technology to include. And then because of air travel, there'd be some regulations and legal stuff I'd have to make sure to cover. In addition to the background research, I did interviews. I got permission from a few airlines to interview their employees and walk with them and the travelers with their permission. And I got to interview them to see their experiences. And I wasn't able to go through security, but I was able to go up to security where the line starts. And the four main pain points that I found were falling injury. So a lot of people, when they're getting into the chair, they kind of fall back into it, and their center of gravity is thrown off. So it's kind of dangerous. Same with getting out of the chair. Those brakes on the chair don't always work, and they kind of slide around sometimes. There's also embarrassment of having to rely on a stranger to push you around, and that's kind of awkward for some people. They don't really like it. And clothing articles and bag straps also get caught in the spokes, and that can also be a hazard. And then back pain, because the soft fabric backs on the chairs, over time they kind of loosen up and they don't provide or little to none support. And then in addition to that, I wanted to go further and delve deeper into this research, and I decided to get a ticket from Phoenix to LA and wrap my foot in a cast and go undercover as a person with ambulatory needs. And I'm glad I did this because I found some crucial discoveries that I wouldn't have found otherwise. That security is actually a lot faster. I thought it would be kind of like a hazard, something that would take a lot of time, but you actually get pushed right up to the front, you get let in the side door, and they pat you down and you're on your way. And then the longest part was actually waiting for the people on the plane ahead of you to deplane. Then the flight attendants could bring your assistive stuff to you, so in my case it was the crutches. And then I had to crutch off the plane and get to the next wheelchair, but that took the longest time. And then also just did some measurements as well. So once I collected all my data, I kind of thought of, the first thing was a motorized device, so that way you could be independent, you wouldn't have to rely on someone else. I looked at Segway technology, because that's a refined technology. I've seen some chairs or some sitting devices that use that for stability, and I thought that'd be a good place to start. I looked at different chairs that would allow you to go from a standing position to a sitting position, adding wheels to that. I looked at different orientations of how to move around. I also looked at a shell design, which would kind of like house all the components and kind of keep you isolated from the internals. And I ended on this saddle or straddling seat design, where I thought this would address the falling issue, because instead of having to fall back into a seat, you could just kind of squat down, and then your center of gravity is below you the whole time. And going from there, I kind of went and made a proof of concept rough model, and just to show that this idea could work. And from there, I kind of refined it with a hubless wheel design, and that would kind of isolate the moving parts and actually eliminate the spokes altogether, which would be helpful. So with the Whiteful model, I just kind of figured out sizing with this, and figured out some of the key features, specifically how it would fold up, because I thought if I had it fold up, it could be able to fold under this and fit under your plane seat, and then you'd have it right there when you're ready to go up at the end of the flight. Okay, here's the final concept, and I'll go into features now. So I used aluminum instead of steel because of the strength to weight ratio. I thought that that would be good for, well, I thought that using plates of aluminum and screwing it together would be good, because it would avoid the complications of aluminum welding. And hard back support, that could be further developed to have some kind of cushioning, but I thought that would just be best way to just support the back. And I talked about independence and use of gyroscopes. Then this is just a simplified exploded view of the hubless wheel, just to show that all the parts are actually inside and you're not exposed to the moving parts. And that's eliminates the problem of getting stuff caught in the wheels and stuff. So then the next thing is how to activate it. I wanted it to be motorized activation in case you had limited strength. So I decided it'd be a push button, so you need an intentional push to expand it, and then 2 fingers to collapse it. And then I just made a short animation to kind of explain that a little bit further. So once it's folded up, it can fit under the seat. And the diameter of the folded device is just under 17 inches, which is it's a little shorter than average seat height, but if you add the seat on top, then it would be actually taller than average seat height. So then that goes to, if you unfold it, you can sit on it and ride it down the plane aisle, and it actually fits down the plane aisle, it's thin enough. And then I went into product development. I'll just kind of skip through this, and longest parts are engineering and designing and prototyping. And this could actually be extended a lot longer if it's product testing and regulations that have to be met and stuff. And then the last thing is just production, and then shipping from Hong Kong to Long Beach, and then product release. And then for future direction, I'd want to go in, I guess this is a simplified just touch screen, so you can update it in the future, but I'd like to look at what's the best controls for people with ambulatory needs to interact with. So I'd further develop that part. And then way down the line, it could be autonomous, and it could be something that you scan your ticket, it knows your settings, and then it take you right to your plane seat, and then it's just a lot easier. And thank you. I'll take your questions now.
I like how you thought about the whole user journey. My mom has started to need a wheelchair when she flies, and so I know, especially around the kind of the social factors that come about with kind of feeling embarrassed and having to wait around for somebody, to kind of push you to the gate. Those are, definitely, I know, issues that she's brought up. I think it'd be interesting for you to explore how, where these things, or what the transition point is like from arriving at the airport to kind of, matching yourself up to one of, your chairs, and then going, all the way to your seat. That would be kind of interesting. I would imagine there's a much better experience in like the luggage cart, sort of racks that you see in all airports.
Yeah.
How could you make that sort of a less stressful, kind of like smooth transition
Yeah.
to actually get into, into one of the chairs. But yeah, nice work. It's a lot of, you can tell you put a lot of thought into the actual product design and the industrial design work, so yeah.
Yeah, a great presentation and very nice design work. I like very much at the beginning you were looking at the cost of the what's out there now, what exists. Do you have any sense of what the cost of this would be, or a target for what you're, where you'd like it to be?
I guess the motors could be like the motors and gearbox. I guess would be the most expensive thing in there. That's like around $300 a motor, and then in bulk it would go down, and then it would just be the next thing would be the aluminum, because it's just a nicer alloy of it. Other than that, I was thinking that it would be bought in bulk by the airlines, so a certain airline could buy this and then kind of market that.
Do the airlines? Is it the airlines that own them now, or the airports that own them now?
They're kind of like by airline, so like they'll have their own colors in there. I'm not actually sure who owns them, but I know each airline kind of has their fleet of them.
Yeah, I think it would be interesting. You identified a very specific problem, and a problem that's got a growing market, but it's still a fairly narrow market. And I wonder, now that you've come up with this design, could you expand that market? Are there other situations where this would provide a set of solutions that in other instances, not just trying to get through an airport and into airplanes. Yeah, I could imagine that there might be other situations where having something that's kind of collapsible and user friendly like this would be very advantageous. Just as you think about it as a product, I think you should explore what those other markets might be.
Yeah, similarly, it feels like it's an amazing product for maybe some other markets as well. I guess one thing that I'm also thinking, having experience of elderly parents that need the wheelchair, they tend to be really unstable, and like my father has a really hard time just getting into the wheelchair. And so one thing that I'm thinking about with these is I'm wondering about that kind of stability for an elderly person. And then it made me think, okay, well, that's where I was thinking about the other markets,
Yeah.
because this seems really great for somebody who might have a disability like on their leg or arm or other kinds of things that might make it hard. But I'm wondering about the stability of an elderly person who has kind of different kinds of issues. Like my dad wouldn't be able to keep himself upright if it wasn't for the back of a chair that kind of hugs you. It might be interesting to think about some of that. I mean, perhaps you did think about that? Yeah.
I did. I wasn't sure how to
Yeah.
incorporate that part into it, so I thought
Yeah.
maybe in like a future model I would kind of go that route.
Yeah, like you could do some user testing with this and see
Yeah.
how, what like exactly would, maybe like it needs an arm thing or something like that.
Yeah, something like that.
Just chime in with that, because that's actually a good point. You can probably instead of like embedding it into it, make it as an attachment, something you just carry on separately. Because I'm looking at the back of the chair, and it looks like you can just slip on to like a stabilizer for like that'll hug around or just like extend out, so the person can like rest against it. To not at least like eliminate that, to like store it away, it just folds up and put it inside the bag, or how you had it like have that back slip inside the chair. You just slip the end to it too, so just make the chair part a little bit thicker.
And there is some space like in the opening that could come out of, like right in the middle.
Yeah, so you can just make an attachment that'll just slip right onto there. And for that, I studied metal, so like I got understand so why you would choose aluminum for this. For that, you can just do aluminum alloy, which is just strong enough. It can actually stand a little more than alloy. Aluminum, what it is. So that attachment slipping onto right there would be the best choice for that. Or you just go with stainless steel.
Okay, thanks.
But I do want to commend you on your thoughtful presentation. You provided us with statistics of why this is important. Like, why is this product going to be more and more important? We have a more and more aging population, and I think that's really helpful.
I had some more stuff too. I just forgot. I got nervous.
What?
I got nervous at the beginning and kind of forgot some of the stuff.
I saw it on your screen. It was good.
Yeah.
No, it's nice to have that framework.
No, and again, if the airlines are ultimately your customer, they're the ones who are going to be buying this. Convince them that this means that more elderly people will fly. They're going to get more customers because they have this, and they will do better than their competitors because they're the ones that have this, as opposed to a sort of standard solution. I could totally see that making the difference for an elderly person about deciding to fly somewhere or not, or deciding what airline to take. So I think it could really sell itself in that way. One other design consideration would be to think about bags. Obviously people can check bags, but they like to have some kind of hand luggage with them, and how would that get carried? Where would that go?
I guess like the quick thing I was thinking of, something would go across the middle.
Yes.
Just stick it in the middle.
Right, that makes sense.
And then also I was thinking that I guess like maybe elderly people right now might not be so familiar with newer technologies, but I feel like the group that's kind of going into that area, into that range, will kind of be more familiar with stuff like this and this technology. So
I think like the autonomous part of it is going to be important, because I'm also just thinking we use that service a lot for my father because of his dementia, but if we knew that, like you code it and it goes to the gate, and like some of this forgetfulness that he has from the gate to the, can be, I think that seems like a real advantage in terms of safety, or feeling safe to have your elderly parents ride on a.
And I was thinking also, like, if you get like kind of fitted for one once, when you scan your ticket the next time, you kind of like adjust to your settings.
Right.
So,
Like car seats can do. Yeah.
Oh, that's so interesting. You have like a scan and it
Something.
kind of like changes, hugs you.
Says reassuring things to you all the way.
It's nice.
Thank you, problem.
Good, thank you.
It's excellent.
Okay, excellent. Well, thank you, everyone. I want to thank Ryan, Jack, and Ruki, and Sarah, who made it in and really hustled to get here. And of course, all of you, all the students who presented, congratulations. To be selected as part of this exhibition is amazing. And I think Emmanuel mentioned it, to be exhibiting in a Smithsonian and having that experience is just fantastic for a young designer. So we're very excited to have been part of that with you. And I truly hope, and I think I've already saw that today, part of this is also not just hearing from our wonderful panel of experts, is learning from each other. I think we learned about everyone's design process and presentation style and narrative, that you kind of take the opportunity to learn from your peers today who presented. And I mentioned earlier when we were on that tour that we have the National Design Awards, so I fully expect in the next decade, or actually we have an Emerging Designer Award, that one of you will be winners and or selected to be a winner in one of the National Design Award category, and it'll be a fun cycle to see you all again in the near future. So we look forward to you joining the panel tonight. And I want to invite you to continue staying connected with Cooper Hewitt beyond your visit today. So thank you, everyone, and for coming. And we'll want to stay for maybe a group shot with everyone, and then we have a light dinner in the back to get us kind of re-energized and stretched out before we start the panel this evening. So thank you again, everyone. So can we